Hey guys, this is Miss Pasquale. I'm going to be finishing the second part of your test review. Remember, your test is on Wednesday. Alright, let's begin on number 12. A city water service has a base cost, so that's my initial value. I know that if I'm going to be writing a linear equation in the form y equals mx plus b, I'm going to have to find my slope and my y-intercept. This base cost is my initial value, so I know right there, $12 is my base value. Anyway, a city water service has a base cost of $12 per month plus a rate of $1.50 per 100 cubic feet of water. Write a function f of x to represent the cost of water as a function of x amount used. Then write a second function g of x to represent the cost if the rate rises to $1.60 per HCF. Alright, so we're going to be having to write two different linear equations, f of x and g of x. And all of it, well, both of them are in the form, the slope-intercept form, where you need to find the slope and the y-intercept. Well, looky here, we already identified our b value, our y-intercept. So for both of these, it's going to be plus 12 at the end. I just need to fill in the blanks. I need to put in my slope. Remember, slope and your y-intercept. Okay, we already know what our y-intercept is, or our starting point. Now for the first one, f of x, they give us the rate of $1.50 per 100 cubic feet. So that's my first slope. Just plug it in. 1.50 or 1.5, it's the same. Okay. And over here it says write the second function g of x to represent the cost if the rate rises. So rate we know is our m value. So the new one is just the rate of 1.6 or $1.60, whichever one. And there you have your two equations, f of x and g of x. Remember, whenever you're forming these types of equations, it's just two puzzle pieces to this slope-intercept form, which gives you your slope and your intercept. Just those two main things. Alright, number 13. Number 13 is using our answer from number 12 to answer the following. How would the graph of g of x compare to the graph of f of x? Well, looky here. The slopes are different, but our y-intercepts are the same. And what we want to remember in our transformations of linear equations is that if the slope changes, that changes the steepness of the graph. So let's look at the slope of f of x as compared to the slope of g of x. The new slope, it's bigger. So if your slope gets bigger, that means your graph is steeper. Also take into account the absolute value. But both of these are positive, so we don't have to think about that. Right, let's move on to number 14. Number 14 actually says graph f of x, then reflect the graph f of x across the y-axis. So let's just do this one step at a time. Let's graph f of x so that we can see it a little better. I'm going to rewrite my equation of f of x. We had 1.5x plus 12. So there are two main steps, again, that you want to remember whenever you are graphing or plotting lines. First step, plot y-intercept. Second step, do the rise over the run, your slope. Two main points. Alright, so the scale on this graph is really bad, so I'm going to change the scale of it. I'm going to go by 2s, and this is what we want to take into consideration whenever we are doing the rise of the run, because if you change the scale, you have to make sure you're careful with how much you rise and how much you run. 2, 4, 6, 8, 10, 12, 14. This is my x and this is my y. Yay! Okay. Alright, so if I'm going to plot f of x, I'm going to use purple for this one. First, plot your y-intercept. My y-intercept is at 12. Bam. Right there. Okay? So now, I need to do the rise over run. But, oh, it's not in a fraction. Don't worry. Let's rewrite this as a fraction. You can use your calculator to change it to a fraction. Just, all you have to do is plug it in, 1.5, and then press math, Enter, enter. That fraction is actually 3 over 2. So I know I'm going to have to rise 3 and run to the right 2 units. But keeping in mind my scale. So from my y-intercept, I'm going to... Oh, wait, look. I'm out of room. So that means I have to do the opposite. The opposite of going up 3 is going down 3. And the opposite of going to the right 2 is going to the left 2. So again, from our y-intercept, I'm going to go down 3, so from 12, 11, 10, 9, that's down 3, and then to the left 2 units. 1, 2. Keeping in mind my scale. I'm going to do it again. Down 3 units, 1, 2, 3, and then to the left 2. 1, 2. Down 3 units, to the left 2. Down 3 units, to the left 2. And really, if you have 2 points, you can form a line. Ta-da! This is f of x. Right. Now that we've graphed our f of x, we need to reflect the graph across the y-axis. Oh, what does that mean? It's using this y-axis. Let me put this in red. Using this y-axis as a mirror. Pretend that this axis is a mirror. I'm going to reflect every single point across that. So my y-intercept will remain the same. And I'm going to graph g of x in orange. Okay. So that means this jumps across right here. This is a mirror, so everything is reflected directly across. So this is 2 points to the left. That means this is 2 points to the right. This is 3 points to the left. This means that the next point is 3 points to the right. Just use it as a mirror. In a mirror, the reflection is the same distance to the other side. Alright, so we've now reflected the graph of f of x across the y-axis. Now we need to write this function, or equation g of x, to describe the new graph. So hey, we have the same y-intercept. So given my y equals mx plus b, I know my y-intercept will still be 12. So plus 12 at the end. Now to find my slope. Well, I have points on here. I can do my rise over run. From 12 down to here, from 12 to 9, that's going down 3 units. And then I'm going to run to the right 2 units. That means my slope is a negative 3 over 2. And because I have my slope and my y-intercept, I have my equation. So guys, a good property to remember instead of doing this all-out process right here is that knowing that if you're reflecting your graph across this y-axis, all you have to do is take the slope and put a negative next to it. Or if it's already a negative, change it to a positive. And that's all you have to do. Okay, number 15. Number 15, this one looks familiar. We've done this one before. Again, now we are applying our linear equations to real life, because that is important. You need to know how this math applies to the real world. How can you use it? Use the following information to answer problems 15 through 17 below. Alright, let's read. An attorney charges $250 per hour. Oh, per? That's a rate. In my linear equation, my rate is my slope. Rate and slope are the same. Okay. So the graph represents the cost of the attorney as a function of time. Select the best answer. Alright, number 15. When a traveling fee is added to the attorney's rate for cases outside the city limits, the graph is translated up 50 units. So this is the original graph. This is the y-intercept. If it was translated up 50 units, that just means that they just moved the entire thing up 50 units. And the slope didn't change. The rate didn't change. It's going to be some sort of parallel line like this. So this one says, what function, h of x, would describe the attorney's rate with the traveling fee? So our rate didn't change, so keeping that in mind in our y equals mx plus b format, my rate, 250, it's still the same. And then I translated it up 50 units, so that means my y-intercept went up 50 units. The only thing that matches is b. Okay, number 16. The attorney's paralegal has an hourly rate of $150. How would you transform the graph of f of x into a graph for the paralegal's rate? Well, we see here that the rate is the one that changed. And when you change the rate, it neither shifts the graph up nor down. That's when you change the y-intercept. The only thing that's changing is my rate. And that changes the steepness of my graph. So we can automatically eliminate G and H because it doesn't do any translations. It's changing the steepness. And let's look at the other options left. And hey, we've already reduced it to 50% of our choices left. So this is good. In multiple choice, use the process of elimination to increase your chances of selecting the correct answer. Right, F says reflect it over the y-axis. Well, if we were to reflect it over the y-axis, that would be a negative slope. That would mean per hour he's paying to do his job. He's losing money per hour that he does his job. That doesn't make any sense. Why would you work to lose money? The only thing that makes sense is J. Rotate it clockwise about 0, 0. What that means is you're taking your graph and you're rotating it clockwise. So that way. And hey, look, you get a line that is flatter. And that is exactly right. Because my slope, it changed from 250 to 150. It decreased. And when your slope decreases, it gets flatter. And another way of saying that it got flatter is that you can rotate it clockwise. So your answer is J. Number 17. Which hourly rate would not make the attorney's graph steeper? So again, going with steepness and flatness, the attorney's graph, or the attorney's rate was 250. So if we wanted to make it flatter, which is not steeper, we want a number or a rate that is less than 250. And the only number on here that is less than 250 is 225. Everything else is greater, therefore steeper. Okay. Number 18. Whoa. Okay. All right, number 18, we have a graph. Sam works as a bicycle courier. She earns $10 for each delivery plus, here's my rate, oh, here's my y-intercept and here's my rate, plus 75 cents for each ounce the package she delivers weighs. The graph of her pay is shown below. Alright, so yes, it starts off at $10 for each delivery plus it increases per weight in ounces. Alright, so this question is asking, what would it mean if the slope of the graph were to be doubled? Well, let's look here. Let's find our slope. Or actually, let's find the equation for this. Not necessary, but I'm just going to do it because I like writing equations. Yay! Okay. Remember, in your y equals mx plus b, b is your y-intercept, or the point that crosses the y-axis, which happens to be at 10. This is technically going up by 2, 4, 6, 8, 10. Right here. I know I'm going to have plus 10 at the end. I need to find out my slope. And given a graph, you can always find your slope. Your slope is rise over your run. So pick any two clean points, and how Miss Bettis refers it to, the crosshairs. So from this point to this point, I had to rise 8, blah, blah, blah. Oh wait, we're already given. We can save ourselves time. It's already given to us. We already knew our y-intercept was at 10. So our slope is 0.75. Or if you want it in a fraction, just plug it into your calculator. 0.75. Math, enter, that is 3/4. So technically, rows 3, run 4. Okay, so it says here, what would it mean if the slope of the graph were doubled? So double 75 cents. Double 75 cents. That means you're going to multiply that by 2, and you do get $1.50. So $1.50, that's more than 75 cents. And if your rate increases, that means your line gets steeper. So really, the line gets steeper. But what does that mean apply to this situation? Well, basically, the cost per ounce doubled to $1.50 each ounce. So I guess, yeah, technically I didn't really have to write an equation. But the lesson here is read what you're given, okay? Sometimes you don't have to write out the equation just by looking at the graph. They give it for you. They give it to you within the problem. So the lesson is read what you have. Okay. Number 19. Number 19. The line graph below represents the elevation of a car as it drives down a hill. Whee! What would it mean? What would be the meaning if the slope of the line were doubled? So again, with slopes and being doubled, okay? So slope, if you change the slope, it changes the steepness. So let's say that you were running down a hill and you decided to run even faster. Does that change the height of the hill? No. No. The hill's height doesn't change. I can automatically eliminate the silly answers here. F and G. The hill would be twice as tall. The hill would be half as tall. The speed, it does not affect how tall your hill is. The hill's height doesn't change. That would be very strange. If there was an earthquake, maybe, but conventional methods, no. Your hill would not change in height. So we could automatically eliminate F and G because your hill's height, it should not change. For whatever reason, your hill does not change its height depending on how fast you're going. Alright, so we're just left with the speed, which is exactly what we're dealing with. Slope has to do with rate, and rate is a speed. So if it were double, that means it's steeper. So let's just do that. Steeper. And if it's steeper, if you go at a faster rate, wouldn't it take less time? So it would be moving twice as fast. The faster you go, the less time it takes to go the distance. So again, just use the process of elimination to increase your chances of selecting the correct answer. Use logic. Number 20. On number 20, we have a graph. The graph below shows the water level in a tank being drained at a constant rate. If the rate at which the tank is drained is changed to 4 inches per hour and the initial water level remains the same, how would the time it takes to empty the tank be affected? All right. So let's look at this. This is an equation of a line. Okay. We know that its y-intercept is at 12. And our slope, well, let's do the rise over run. I went down 2 units, and I went to the right 1 unit. Down 2 over 1, that is a slope of a -2. So if I were to change it to 4 inches per hour, my graph would look like that. So it's being drained at a faster rate. That means it'll take less time for the water to drain. So let's go ahead and plot the new line and see what it looks like. I know that with this new slope, I still have the same y-intercept, so I can still use this y-intercept as a reference point. So I'm going to go down 4 units. So from 12 to 8, that's down 4 units. And then I'm going to the right 1 unit. Because technically my slope is -4 over 1. If it's not in a fraction form, force it to be a fraction by putting it over 1. That is acceptable. It is equivalent. So I'm going to do the same thing. Down 4 units over 1. Then I know some of you guys are thinking, hey, this is only 2 units. No, look at the scale. Don't let the scale trick you. Okay, this is from 8 to 4, so that's 4 units down. Another. There's my new line. So instead of taking 6 hours to drain, it takes 3 hours, just at that different rate. So it would take 3 fewer hours. Basta! Number 21. We're almost done. Yay! I mean, no. We love math. It's so amazing and fun. Yay. Alright, number 21. Victor Zavala drew a line through the points that represent his initials. Okay, so his initials are the first letter of his first and last name, VZ. Which equation best represents the line which Victor drew? Alright, let's go to our graph. Where's V? Oh, it's right here, and here's Z. So I'm going to draw a line connecting those 2 points. Right, so here we can see the options are given to us in our slope-intercept form. And this is really great because you're given the answers, or you're given multiple choice. You can just, again, use process of elimination. So let's observe what the y-intercept should be. Y-intercept means the point at which your line crosses the y-axis right here. I can see it's going to be a really big positive number. So I can go down here and eliminate all the non-big positive numbers. Oh, B, the y-intercept is a negative 11. That's out. 11 divided by 4, if you were to change that into a decimal, that is not a large number. So you can also eliminate C. Right? Now we are limited to A and D. And notice here, look at our slope. It's going down from left to right. That means if it's going down from left to right, that is a negative slope. And vice versa, if my line were to be going up from left to right, that would be a positive slope. But in this case, because it is going down, I have a negative slope. So the other answer I can eliminate because that's a positive 4, so my answer is A. I didn't really have to write it. I just had to eliminate the answers and see which one best represents my line. Number 22. What is the equation of the line that has a slope of negative 2/3 and passes through point X? Okay, well, point X over here is a okay, here's point X. So negative 2, 7. Negative 2, 7. So point X is actually negative 2, 7. Alright, so there are multiple ways that you can go about doing this. The first time I didn't really read it and I went the long roundabout way of doing it, but there's a way to avoid that long tedious process because, hey, look, we're given all of the answers. And what you do notice, the only difference in all of these answers are the numbers right here. The 2x plus 3y, it's constant throughout. So what I did after that long tedious process, I was like, hey, I can really just plug in this point, this x value, and this y value into this form and see what number it comes up with. So that's exactly what I'm going to do. I'm going to plug in negative 2 in place of x and a 7 in place of y, because I know that if that specific point lies on my line, it will satisfy whatever equation over here. So I have to see which number it matches up to. So you can use your calculator or you can do this manually. I'm just going to do it manually because I love math. 2 times a negative 2 is a negative 4 plus, and 3 times 7 is a 21, and negative 4 plus 21 does give you a 17. And here it is, option A. But again, there was other ways that you could do this. You could have used the point slope form and found the equation and tried to change it. Whoa, where did that other paper go? Again, you could have used the point-slope form and try to plug in your slope in that point and then solve for y and then try to change it back into the standard form, but that takes so long. Using your knowledge of mathematics, you know that if a point lies on a line, it'll satisfy that equation. And that's all I had to do, as opposed to this long drawn-out process. So be smart. Work smarter, not harder. Alright, that will be it for today. That is all of your review, so no excuses. All of this is on YouTube, which you can tell because you're watching this. And if you have any questions, you can ask Ms. Betos, Ms. Elizondo, you can ask me, I'm Sensei, or Ms. Pascual. I'm usually running around. Alright, have a wonderful day.